thought it was she was 5'3", I was like, do you think she's I think she's 5. I think she's 5 too. They have to be like 2 inches taller.
All right.
Unless you're
suddenly 5'6" and I'm 5'8".
She ended me in the hallway. That's so funny. That's good to know.
Okay, so folks at home, folks here, take a look at the Canvas announcement for today, because I just have a couple things that I wanted to mention, so you know kind of a plan that I have going forward. Put this back on, sorry. So I want to first start by looking at the answers to that 1.3 stuff. So let's do that now. Take out your work. Now, most of them we did in class, so I don't think we have to stop and really look too closely at a lot of things, but you may find that it is helpful to just take a peek, put a check mark next to it if you got it right. Now, A through D, or at least A through C. I know we did most of these. So, but just kind of one by one, just take a look. Now is the time to ask questions on these 3 pages. Anything ABC? Okay. Sorry, E is -5/2. I made that mistake. I will re-upload this, so that's fixed. That's why I write in pencil. Even the math teacher writes in pencil, because I made 2 mistakes. One of them I caught before I uploaded this, and this one I did. D is obviously pretty tricky. So like you can see that I did some side work there. Like I separated my process of connecting equivalent expressions with the limit, and just kind of off on the side, I said, all right, I need to figure out what tangent of 5π/3 is, because my calculator gave me a decimal that I can't use. Now I'm always going to try that. I'm going to let the calculator help me if it can. I'll just use it. But I got -1.7 blah 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 blah, and I know that's not an answer I can use. So I had to kind of slow down and evaluate that by hand. So you'll see you might have to do that from time to time, especially with some trig stuff. Speaking of trig, would anybody like a printed copy of the trig cheat sheet so you have it handy? Cohort B, I'm gonna hook you guys up tomorrow. Save this, laminate it, put it on your bed at night. So you learn it by osmosis. That always worked for me with science. Anybody else? Cool. I have lots of copies, so just feel free. Yeah? Go. Okay. Moving on. So I want to give you lots of time to work today. There's F and G. Now, I didn't really need to factor F to know that there weren't going to be common factors. I just think it's a good first thing to try. So you don't have to. You could have jumped right from here to here and just left it as x squared minus 9. So 3 squared minus 9 and got to 8/0. That's okay. I like to factor anytime I can, so I know what I'm working on, even if it doesn't work. So feel free to think about the factoring. If it's easy enough, like x squared minus 9, to do in your head, and see if it's worthwhile to write that out. Does that make sense? You know what I'm talking about? Okay. And there's G, difference of cubes. I left up the setup for that with a cubed plus or minus b cubed over there, so you can see where all that stuff came from. It doesn't happen often, but it does happen, so good to know. And important to keep the parentheses around this polynomial right there, so we know we're taking the limit of a. Questions, F or G? There is H. We did this one together, but I know we went through a little quick, and then I didn't keep it up forever, so If you got to 1, you probably did it right. It's kind of hard to fall backwards into the right answer by doing the wrong thing. So if you get the right limit, you probably did it right. But there could be a mistake along the way. And I mean, I'm looking for like parentheses, making sure if you open them, you got to close them, and simplifying correctly and holding on to the limit notation as long as you're supposed to, but not a moment too long. All of those important kind of math grammar things, right? Making sure that our notation is correct. Questions on H? Yeah. I was just a more fun version of that. Multiplying by the conjugate, of course, not changing anything except the sign between the 1 and the square root. Show more steps, show fewer, but definitely show enough so I can follow your process. If you leave too much out, you will not get full credit. So err on the side of more work, not less. But like neat and organized and clear and obvious, all good things to try to strive for in calculus as things get just trickier, right, as we go. And you can always confirm your answers graphically. You can plug that function in and just look at it. Get super close to 1. You're going to see that we're moving close to -2. And you can do that in your table, right? If your table is set to ask, you can go, okay, I'm going to go to 0.9 and 0.99 and 0.999 and 1.1 and 1.01 and 1.001 and make sure that you're actually moving towards a number like -2. That's not algebraic proof. This is, but man, that does feel good to have your calculator back up those initial thoughts. And these, obviously, you guys in front of me, this is all on campus, and we'll stay there so you can check it out. Let's see if we'll put the people writings. You can check this out on your own if you need to. If like you didn't do it at all, you were completely lost, you can go back and copy things down later. I just want to show you J again. I know we did this one. This is not a question I would ask on a quiz or test. I will say that right now to save you from the headache that these questions can cause, but they are really good ones to keep your skills with complex fractions a little sharper. And you will see in the practice that we will do, that will start today and work through into tomorrow, I will allow you to skip the 2 questions that look like this, but I am going to do them in the solutions, and I urge you to try them. Why not? Okay. So there'll be 2 questions like this in the practice that's not due today, but due tomorrow, that look kind of like this. I haven't gotten through all of them, but the first one actually does have a limit, which was nice to get to, because this was kind of frustrating to get to, does not exist after doing all that work. And the key to that was right here. That from the beginning, I don't get 0 over 0. I got 1/2 plus something undefined. My numerator is undefined. My denominator is 0. It's not 0 over 0, so I can expect that it's going to be an asymptote and not a whole. And there's K. I'll scroll down to L and M here in a second. But these last 3 were our one-sided limits, where we wanted to actually see what direction we were heading as we approached an asymptote. But to make my future steps that much easier, I factored in simplify. Even though plugging in 2, it's not 0 over 0, so I know I'm approaching an asymptote, right? It's 12, 14, 28 over 0. It made my process a little bit simpler once I got to the point where I just plugged in a number close to 2 on the right-hand side. Now, I did this in class yesterday. You guys were home. But this factoring super crazy awesome shortcut is something that you probably heard for the first time, most of us, yesterday. So I want to talk through that process again so that it's really clear what you can do. Factoring quadratics where A isn't 1. Last semester, we did like factoring by grouping, right? Where we thought about, okay, 2 numbers that add to 7 and multiply to 3 times 2, 8 times C. And we got 6, and okay, so my numbers were 6 and 1, and we split that up into like 3x squared, 6x, 1x, and 2, and whether it was the 2 by 2 square or you factor by grouping, we got ourselves down to here. There is a faster way if you'll allow me. If your numbers are 6 and 1, then write it like it's a x squared, not a 3x squared. Knowing that that step is not correct. It's just an in-between step to help me get to the right answer. And what's amazing about this process is it works exactly the same as factoring by grouping. The key to this, though, is knowing that when A is different, you have to see if that A value goes nicely into the numbers that you have. If it divides perfectly, 6 over 3, okay, cool, I'm going to divide it. X plus 2, definitely going to be a factor, guaranteed. But if it doesn't, make sure your fraction is simplified and take that denominator and move it in front, and now it's your coefficient. Now, I'm doing this in Algebra 2. We're doing like a whole quadratics thing. So I've done literally like 100 of these, and it just works out. Factoring by grouping is happening in the background, but this is a much faster, super easy shortcut to get there. Okay? I'm happy to show you more examples as it works out that way. But what was really nice about being able to factor is that I could divide away, it's not the problem, but at least I could divide away something to give me a simpler limit to work with. Because now as I approach 2 from the right, well, all right, I'm going to plug in 2. All right, 7 over 0. It's an asymptote. Which way? Well, let me plug in a number to the right. I got 73. The sign of that number is the only thing that matters. So I know I'm going to positive. Okay, so when I ask you for one-sided limits analytically, this is how this happens. Now, I like the way that I wrote my work here better than I did yesterday. I like this one better because what I did yesterday is I just kind of connected it all up with a string of equal signs. And eventually I said that 73 equals infinity, and that just bothered me really deeply to write that statement. And so what I like about this is I separate like the connection of the limit. There's the limit, it is infinity, from a little bit of side work here, either below it, off to the side, somewhere else that shows that. And I like that a whole lot better. It was very informal and almost too much so the way that I did it yesterday. So start doing it in some way that you are not connecting a number like 73 and infinity with an equal sign. I think that that just looks sloppy. Does that make sense? Okay, cool. L&M, there you go. And there it is, right? A little side work underneath to plug in that number to the right of 3. So 3.1 is always good. 3.01, 3.001. The closer you get, the more comfortable you'll be with your answer leading you to a limit like infinity or negative. Okay. Again, this is all up on Canvas on today's announcement for you to check out. Questions at home? Lovely people sitting there, cohort B, all good? Sweet. Okay, so I will, of course, I will leave those solutions up so you can check those out on your own. But I do want to get to the point today where you actually have time to start practicing. And so if you look back at today's announcement, you will see that I have homework 1.4 ready for you to start. And it's just, okay, turn to the next page. Go ahead. Turn to it. Turn to page 29. And what you'll see is they called it like homework 3 or something. But what we'll do is we will take these 3 pages, and I'm going to give you some time to work on it less with me and more on your own. Okay? Where you just ask questions as you run into it. But there are 4 questions in there that I do not mind that you skip. Okay? 2 of them being those complex fraction rational ones, 2 of them being piecewise. Okay, and I am okay if you skip those. In my solutions, I won't. So you can see how they're done, but I didn't want to waste precious class time working on things that will not be on the quiz that we will eventually take by the end of this week. And so as you take a look at those, I'm just going to jump back into here so you can see it. These 3 pages, so no 10, 13, 18, or 19, but everything else, it's not due until tomorrow before midnight. Okay, so you'll have today in class and tomorrow in class to work on it. I'm trying to avoid you having to do too much outside of our class time, if at all, because I know you have lots going on. So keeping that in mind to get you ready. Now, this is not enough practice to get you ready for the quiz, because the quiz also has graph stuff on it. So you guys in front of me are going to get something right now. You folks at home are going to get this from me tomorrow, but it is sitting online as part of the PDF of the entire chapter. 2 practice quizzes, okay, designed by the people that wrote this. Okay, there are going to be some questions in there that we will skip, piecewise stuff and things that we just haven't focused on as much. But this kind of gets you more into the style of questions and how they're going to be asked, more than this practice does, okay? This is optional. I'm not going to check it. You do not have to upload it. It's for your own benefit if you want, okay? To just get some style questions that you're going to see with like different kinds of multiple choice versus different kinds of free response. But also it helps you kind of go back to the graphs and just practice, okay, like evaluating limits versus evaluating just the function, stuff like that. So I'm going to give this to you now, but this is not something you have to do. It's something you can do. I would suggest that you at least do the graphical kind of thing, because it's been a week since we've done this. Yeah. So there are 2 practice quizzes in here. I will put the solutions to these quizzes up on Canvas as well. Because what we will do, is we are going to get the quiz from me for the first half of chapter 1 as soon as I write it. And it is not due until Sunday before midnight, okay? It's not a like start and you have an hour. It's not timed. Start it and do it however you want. It will be exactly in the style of these practice quizzes, okay? A section of multiple choice and a section of free response. So, but it's going to exist online. So I'm going to send it to you kind of like I have in the past with a Google form, probably, where all of your multiple choice questions, you can just click, 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 and away you go. And any questions that require work, like stuff like we've been doing, or you have to draw a graph that has certain limits like we've done in the past, you just hand write those and then upload them to Canvas, like we have in the past few tests and quizzes. Okay, Jordan, did that answer your question?
Oh, yeah, I can ask one.
Yeah, so a section of multiple choice and a section of FRQs for sure, because that is what the AP test looks like, and that is what I'm going to start preparing you for. Even if you're a senior, I'm going to get you used to that style, okay? And we don't take an AP test. But you will next year if you are an underclassman, so I want to get you ready for that, okay? Now, there's the entire PDF of chapter 1. It'll actually take you to the page on Canvas where you can click on it, and 109 pages or whatever in case you want to jump to the answers ahead of time, because the answers to these are already on Canvas, the practice quizzes, I should say. Okay, so today with our last half hour, last half hour or so, take some time and work through 29, 30, and 31, those 3 pages right there. And what I will do is I will put up not all of the work, but just the answers to a collection as we go. And if you're getting them right, yay, move on. If you're stuck on something, I'm happy to work through them with you, okay? Folks at home, decide if you need to stick around for that or not, okay? You guys will be back in class tomorrow, so you can ask questions when you get back. But if you want to, you can take off, and I will see you tomorrow. You can come back if you end up having questions today and you want them answered before tomorrow. That's cool too. But otherwise, you guys are good to go, and I will catch you back here tomorrow if you'd like. Let's put some tunes back on. You can put some music in your ears if you want. I'm going to put on some, like the music that you heard on your way in, just so we have in the background. If it bothers you, just let me know. I'm going to pull up this. And I'm going to kind of keep working on the solutions. But I've done the first, like, 10 or 11, I think. Did I not get you one of these?
No.
Save the best for last.
Thanks.
So let me scoot this out of our way. Yeah, I have the first 12 done. And you'll see that as we go, these definitely start to get harder, which is good. But I'll put the first 4 solutions. And we'll just work. Talk to each other, talk to me. Folks at home, give me a shout. Should you need anything, I'm here for you.
Wait, Rosie?
Yeah.
I'm having a dump on there.
Okay.
Sine is X. Y.
Cosine and sine are our 2 options, right?
Yeah.
What comes first in the alphabet, X or Y?
Aha.
X.
Cosine, sine. What comes first in the alphabet? C for cosine. So cosine is X, sine's. They're both alphabet. That is a much more common question than you realize. So don't feel like it's the dumbest question you'll ever ask. I've asked way dumber questions than that.
Alphabet, okay? I have really bad kindergarten.
I definitely go through, like, in my mind, like, ABC,
That's what I'm doing.
Nothing wrong with that.
Most is bullying.
I'm not.
I'm better than you.
Shots fired.
I think I should move.
Oh, no.
At least I know my alphabet. So.
So the issue with 6, that's a good one. We really haven't looked at one like this. So say that part out loud. What happens when you plug in 0? What do you get? Do we get just is it defined or is it undefined?
It's fine.
Okay, you get the denominator 0.
Yeah.
Well, what kind of undefined number is it? Is it 0 over 0 or is it something else over there?
It's something.
Well, let's try it. Plug it in. So 0 plus 4, so 4 squared.
Oh, yeah. So just keep it.
So that's a whole, right? So I feel really good about being able to find that limit. And so the two strategies that we have so far are factoring or rationalizing. It's not factorable necessarily. I mean, it kind of is. It is the difference of two squares. It's kind of sneakily written like that. But so if you don't notice that you could do like factoring by difference of squares, we could just expand it. Like you could just multiply it out.
Yeah.
Because if you get 0 over 0, there has to be a way for us to find a common factor and divide it away. Has to be. And so I think you have two choices here. You can just like multiply that out. And you can go Pascal's triangle with binomial expansion. Or you can just do x plus 4 times x plus 4 and distribute the long way if you want. You're going to see that once we get to, I think, 11, it's got a cube in it, so you may want to use binomial expansion with a cubic to help you do that, but that's something that maybe we don't have super fresh, but you'll see that that's the way that I do it. And so you could just say, okay, x plus 4 times itself, there a limit, got to be the limit, sorry. Limit as x approaches 0 of, and then up top there, I'm like just multiply it. Get rid of the parentheses. So what's circled in red right there is that. All right, x squared plus 4x plus 4x, so plus 8x plus 16. The expansion, I'll just write it over here, but a plus b squared is a squared plus 2ab plus b squared. That's what I'm doing. First thing squared, 2 times, multiply them together, and then multiply them. And then you got like 16 minus 16, right? Those two 16s will add to 0. And you get to here. Now what? Nothing's changed about the function. We're just writing it differently, so it's still gonna be a whole. It's still 0 over 0. What do I have to do first? I can't divide until it's factored. Factor first, simplify second. Take that x out. X plus 8. Now I can divide it away. Got to leave the parentheses around it because it's polynomial. Oh, also, look at number 2 real quick. I do not like that there aren't parentheses around that whole cubic squared minus that whole thing. Put parentheses around all of that. I'll go back to it so you can see exactly what I mean. But now just plug in 0, and you get 8. If it's a whole, it is a removable discontinuity, which means we can remove the problem algebraically somehow, for sure. And just so that once you get there, you see it, a plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. That'll be for number 11. It's just weird because it's like 2 plus x cubed. So that's 11 when you get there, I think. Yeah. Now, this, number 6, is difference of 2 squares. So if you really wanted to, and it's kind of neat to like use that it's a little sneaky way of seeing it, and number 11 is difference of cubes as well, so it's gonna work either way. Let's just see what that looks like. I'll come back. Please come back. Thank you. I bet I'm back to page 1 though. Yep. Six. I guess I was zoomed in a little bit. Zoom on you. Let's try. That looks better. So it is the difference of two squares. So if you wanted to, if you saw it, two sets of parentheses. Square root of the first one goes first, so x plus 4. Square root of the second one goes second, 4. One's a plus, one's a minus. So you end up getting x plus 8 and x over x. Right? Square root of the first one, because it was x plus 4 squared, so I take the square root of that, I just get what's inside. Square root of the second one goes second. So like x plus 4 is the first thing that's being squared, right? So what's the square root of that? Well, get rid of that, x plus 4. So that's trickier to see though. So expansion, always a good choice. Always a good choice. It's just longer sometimes. And you're gonna see that when you get to 11. You can see what my second page looks like. It's pretty busy. It's pretty busy. So, but there you go. Let me put up some answers for the other ones while we're here. But let me backtrack real quick just so you can see what I meant for number 2. Do this. Do this. Yeah.
How do you start number 5?
Number 5 is one of those ones where it's probably gonna be ugly with radians and tangents and square and stuff, but the only thing that I'm worried about with a function like tangent is dividing by 0 because it's sine over cosine. And so I'm worried about like cosine giving me a 0, but that only happens at pi over 2 and 3 pi over 2. And this is at pi over 6. So I feel pretty good about just jumping into it and just plugging the number in. So I'm going to start this by saying, okay, you want theta squared? Okay, so pi over 6 squared times tangent of pi over 6.
When I got like a really low, 0.0.
I would love if it was rational, but it's not.
Okay.
And so that means that we're going to have to probably evaluate that by hand to get the right answer. So I have to figure out what tangent of pi over 6 is. Now, tangent of pi over 6, we know that tangent is sine over cosine, right? That's tangent. And so I'm going to use the unit circle. I'm going to go to pi over 6. And if it's sine over cosine, that's y at that spot divided by x at that spot. And so if I look at my unit circle, what I see is that y at that spot is 1/2 and x at that spot is radical 3/2. And you're just going to have to simplify this out and just see what we get. Two complex fractions, or two fractions within a fraction, so a complex fraction, but they have the same denominator, so at least I can divide that away. So I get 1 over radical 3. And that's the decimal that you got. That's what that is. Now, calculus, you do not have to rationalize the denominator. You can leave it like that. So you have a choice to leave it like that in blue, Or you can do what I'm doing in red. If it just bothers you, you can rewrite it like this. So I'm going to use, that's not the answer. Let me back that. I'll circle that. You can use the blue version or the red version back in here now and just evaluate. So pi over 6 squared, so pi squared over 6 squared, okay, times either one of those answers. And so the red version, I'll stick with the red because I'm doing red. Like I could just do that, right? Multiply by tangent. And so that would give me pi squared radical 3 over 108. And that's a very fine answer. Or pi squared over 36 times the 1 over radical 3. And just multiply across, pi squared over 36 radical 3. If this was a free response question, if this is an FRQ, which it is right here, right? Either one of those is fine.
Okay.
If this was a multiple choice, only one of those answers would show up. And so if you look at the red one and say, oh, my denominator doesn't have a square root in it, that must mean that whoever did the answer rationalized it. Versus something like this, oh, there's an irrational denominator. Oh, then they didn't care about it, so I could take the simpler route. And I like both of those answers. I don't know, I almost like the blue one even better. Numbers are smaller, less work for me to do. Why not, right? So that's kind of the thought process behind that one, is like thinking, okay, can I plug it in? And if you're not sure, like separately typing in tangent of pi over 6 like that, great idea. Hey, I got an answer, sweet. That means I can use it. If it said error, undefined, or error divided by 0, or something like that, okay, it's undefined at that spot. All right, let me see what's happening. Is it a hole at that spot, or is it an asymptote?
Okay. Thank you.
Yep. So there's 5. What was 6? 8, right? After all that?
Yes.
Okay, good.
I was like, really?
Yeah, 2 questions, like almost the same amount of work. 8 versus pi squared over 36 radical 3. So last 10 minutes or so, I'll put up some more answers before you go.
Mine is really hard.
9.
It's just a lot of really big exponents, but
Factor.
makes it really
Factor. Divide. Evaluate.
Can't you just like factor out x squared?
That's it. Top and bottom is all we can factor out is x squared. But once you do that, now plugging in 0 is no problem. Because you plug in 0 up top, you get a number. You plug in 0 on the bottom, you don't get 0 in either spot because you've taken out that x squared.
So can the x squareds cancel out
Yep.
immediately?
Mhm.
Okay.
Yep. Here, I'll show you the start of that.
I just was like unsure.
I'll show you the start of 9. Go away. So limit as x approaches 0. So factor. GCF is always the first thing I look for, and that GCF is x squared. So 5x plus 8. GCF on the bottom, also x squared, 3x squared minus 16. So these are gone. I like to write the simpler function before I consider evaluating. 5x plus 8 over 3x squared minus 16. But like imagine plugging in 0. Okay. 8 and negative 16. All right, so I can do like 5 times 0 plus 8, that's 0. Over 3 times 0 squared minus 16. I can show that step. 8 over negative 16. Again, 10 is one you can skip if you want, but it's a fun challenge. The good news is that it does have a limit. That's always nice. Because you would get 0 over 0 if you plugged in 0. And it's not too bad. You just create common denominators, put them together. Just got to be careful because you're subtracting. And I'll say this now. Take a look at 12. This is what we're building towards chapter 2. We've done stuff like this, chapter 1 of pre-calc, where you've got 2 different placeholders. We've got x and h. But look, we're letting h go to 0, which means x stays as x. So when you, and I'm just going to expand. Like for number 12, even number 11, I'm just going to expand those 2 parentheses out. I'm just going to multiply everything out and see what cancels. And I'll tell you, both of those limits exist. But with number 12, because h is the thing that's going to go to 0, you're going to have x in your answer still. Your answer is going to be a polynomial that has x in it. And that is the start of something very big for us. 12 is just a little preview of where we are headed first half of chapter 2.
Does this have to do with that one thing you did a long time ago that you're like, this is the
And what's that called?
It's been a while. Difference quotient.
Yep. So we evaluated the pre-calculus difference quotient. Now we get to do calculus with it. And let h go to 0. Because imagine like h going to 0. Okay, this is f of x minus f of x. What's anything minus itself? 0 divided by 0. So what exists at that spot? 0 over 0 is always a whole. So does that limit exist? Absolutely. We just get to figure out what we're actually finding. Oh, I can't wait. I'm so excited. So, chapter 2 is the best one. That's when calculus starts. Chapter 1 is just, okay, let's get, what does the limit even mean? Chapter 2 is, all right, let's use the thing to melt our brains for a little bit. It's going to be so fun. It's going to be so fun.
Okay, now I have to.
So last few moments. So finish up where you're at, because in 3, 2, 1, we are out of here. Finish this up tomorrow. Just you guys here in front of me, you guys can just jump on and stick around as long as you want tomorrow. Ask questions, like watch me work through stuff as we get to the back half. We start to get into some one-sided limits on the back there, but like 18 and 19 are the last 2 questions, and those are optional. You can skip those. So really, there's only 2 one-sided limits, 16 and 17. But some tricky ones, like 13 is the piecewise one. I did it, so I'll show you what that looks like and how to evaluate piecewise limits at that break where one function stops and the other one function ends. You just see I just go from the left and go from the right, and I see if they're the same. Submit that work for these 3 pages onto Canvas before midnight tomorrow. Do the quizzes as practice. If you want, I would say focusing probably mostly on the graphical stuff, right? Because now you've got a ton of practice with the algebraic stuff. I'd say your graphs are probably your bigger focus, just to make sure it's all covered. Cool? Adios.
Thank you.
Come on, kids. Pick a red one. See ya. Thanks, everybody.
I didn't get an application, but yeah. I just got a new. I got another.
Yes, those over there are the trig cheat sheets. Help yourself if you need one.
No, that's just.
Bye. Have a good day.
No, I got 2 emails.
Take a red one. No, it doesn't matter. But once you do sit, I'm gonna figure out where you are, so I can just write it down. So we can turn the desks the other way, because we have to do that for 6 anyway, so let's just do it now.
I bet.
Let's get this thing swung around, because then we'll be ready to go.
We don't have outfield today, right?
We do not. Now that we're back, I don't really have quite as much time Monday, Wednesday, Friday to get out here.
This homeroom right now, right?
This homeroom, yep.
Does it matter where we sit?
If you want to just sit in the same spot that you're going, like you normally sit in during 6, and I'll put up the seating chart in case you do that. Because here's what at least I had for you guys. Let's see if I can find it. Period 6A.
Okay. Hi, Rosie.
Oh, what's up, y'all?
What's up, boys? Cody.
What's up, boys?
So front of the room being over there. So this is the back right here. This is where I had you guys. I'll put the numbers on the desk too, but let's get them spun around and let's back them up. Like move back, scoot back, scoot back, scoot back. What's up, boys? What's going on?
Going to an extended lunch.
Oh, sorry, got some. That sounds good. What are you getting me? You give me a little treat?
I mean, if you want one, I can stop by and deliver a little food off.
No, I'm good.
Sure.
Listen, if you get inspired, you're like, I think Rosie would like that. I'm down. No, I'll eat it.
I will listen.
So you got something that
My coffee was good.
I'm down.
I can't
Yeah,
remember
well,
that
I believe
conversation.
I'll always take coffee, that's for sure.
Uh-huh.
I will always take a cup of coffee.
No, you know what I did? I was in my truck and I set my shoes down.
Yeah, just because it's like it's weird to be so just like it's filled. Like would you really ever be this good?
I like
I never was. You know what I always was? I was always this. I was always here. I love taking the front corner because I could sit like this and I could see everything.
I like
the back corner.
And I would like move my desk like up against the wall too.
Back there, like nobody.
I know,
You just like see everything. Nobody talks to you back there. Just like in your own little.
Rose, I got my year ago memories when we were in here with Eric playing his guitar.
Nice.
Last year was by far my favorite year of high school. Like
You still have that like
right here.
Yes.
We sat right
Yep,
here.
there it is.
Where she set the lamp down.
Should the lamp down, let it on. That same lamp right there.
Oh my gosh, it was a good memory.
It was, man. That was a great time.
I met you in this
Class was
class
so
like
fun.
over a year ago.
I love it.
I didn't know
Right
it was
here,
you
yeah.
too.
Right.
We started the first
New York
day
City.
in this class. We started talking. Like, I don't know.
It was a good time, man.
Yes.
Yep. Algebra 2. It's one of my favorite classes to teach.
That was so easy. I'm not doing well in this Gibson's class. Yeah.
And what's crazy is like you guys like look at this, and I mean, specifically you three, like, I feel like you guys get this, right?
Yeah.
Like imagine August. Imagine we walked in August, and I was like, all right, like plug this into Vertex. Like find the Vertex, plug it into Vertex form and solve it.
Okay.
You'd be like,
I've never been good
what?
at math.
I don't know any of that. Like, what are you talking
Yeah,
about? Now we're like,
I'll never be in that.
I'm not sure if I still understand. One thing I can say is nothing against Gibson, but I've never had a better grade in math until you were my teacher.
That's what I'm saying. I've never had a beat ever. I'm gonna do right now.
I had a better
grade
grade
in Sigmund's class just because I turned in all my homework, but this was definitely the best.
Like I
I'm so
enjoy
happy.
Special side note for you, Cody. My wife is going to strangle you if you don't get your stuff together.
I got it on. I got a 10.
Okay.
I got it done. I got like
If you're working.
I got a 20 out of 20 on my
She was like, you ever taught Cody Nolan? I'm like, yeah, I had him last year. He's like, oh, he's driving me crazy.
No, it's because Gion was talking to me.
Well, that's class. It's a crew, man. It's
Well, with
definitely a crew.
Sebastian Ziegler and Gion, they were talking to me, and I gave a presentation, they were laughing at me, so I was laughing back.
Yeah,
And then
it's,
she got mad at me.
it's all good. It's a fun class. It's all good. So, she's tough, man. You better watch out. Stay on her good side, and she'll love you forever.
I'm
Get on her
not-
bad side.
Wait, Cody, what class do you have?
not want to be on her bed slants.
Do you know what time?
Because remember when I saw Ken-
So this goes like 11 to 11:35, I think. We're gonna have like a half hour, but the next class doesn't start till 12:30.
12:30, so that's.
So period 6 is 12:30, yeah.
Okay, so we got an hour and a half. Let's go to this Cheesecake Factory or something. I was on my telegram.
I don't know, because it's next in the morning, you can valet your car and stuff.
Are you going to Park Meadows?
No, I don't think.
I actually have to go.
That seems pretty far.
I have to go help him with the chores.
All right, cool.
No, I was doing hammer.
I don't know. I want them to see us.
Let's go with the cheesecakes.
Actually, I've never had the cheesecake.
I'm still recording. Oh my gosh.